Hello guys. Today I would like to talk about the power supplies, about the laptop power supplies. Let's go ahead and check how does the laptop power supply look like. Okay, we call them as M uh, SM switch mode power supply. Okay, let's go online and check for SM power supply. Yeah, so they are showing a switch mode power supply is an electrical power supply that incorporates a switching regulator to convert electrical power is efficiently. Okay, so how does this power supplies work? Simple. I want to explain everything. Let's say laptop motherboard. Okay, let's just open any photo. I'm pretty sure you are wondering how does the whole laptop work. So in this video I will explain how the whole laptop work, how does it convert a certain power into a certain power. Okay, so we use switch mode power supply. Okay, I have a picture here. Let's try to open another picture. This one is not opening. Save image. Okay, here we go. Okay, anyway, I can't open this thing. So what I'm gonna do, I'm gonna take a screenshot. Okay, there we go. I have the screenshot here. I'm gonna take a screenshot. Okay, so now let's go to our desktop. I'm gonna open this picture. Anyway, let me just come here and go to file, open. desktop. Okay, so here we have the SMP power supply. This is the power supply. This is the power supply for the CPU. Let me try to drop this so that you can see. Just run this party. Okay, so here, as I was saying, okay, let me select my marker to be red. Okay, let me just select white. Simple. Can I use this? Yeah. This is the SMP power supply. Okay, you will always have a coil, and then after okay, first of all, you will have a certain chip, a chip that generates that certain power, a chip that controls the two MOSFETs, and then here are the two MOSFETs. Okay, after the MOSFETs, you will have a coil. After a coil, you will have an electrolytic capacitor, or you will have the titanium capacitor. Here we have the titanium capacitor. After the titanium capacitor, and then we have maybe a CPU, or we have the output actually. Okay, because the aim of the power supply, it takes maybe the aim is to take maybe a certain power rail, let's say for 19 volts, and try to convert it into maybe 1 volt, 2 volts. You understand the thing. So it's always the case with the laptop. They use the 19 volts coming straight from the charger. Let me draw this thing. Let me try to open a sheet. Okay, new MC flipbook. Don't save. Okay, here we go. I can't draw anyway. I'm gonna give it a try. Okay, no, let me change color. Okay, it's can't be white. Okay, let me just use black. Okay, so you will have the 19 volts. This is the 19 volts. Okay, it's coming from the charger. When I say charge, this is for a charger. Okay, anyway, you'll forgive me guys, can't write a good thing. And the charger is plugged in here. This is a laptop charging port, and then this is the motherboard. 19 volts is circulating all over the motherboard. Okay, so let's say here we have the CPU. This is the CPU. Okay, so the power supply, usually the CPU, it uses 2 or more power supply, but I'm gonna draw one power supply so that you will have a clear understanding of how power supply work. Okay, we'll have a power connected here to a 19 volt. This is 19 volt. This power rail is 19 volts. Is coming from the charger, as I was saying. Okay, this goes down here, and then it's connect with one MOSFET. This is a MOSFET. We're gonna talk about the MOSFET on the next video, and then they connect somewhere. Then we have another MOSFET here. Okay, and then this MOSFET is connected to ground. Okay, so as I was saying, always you will have a sensing chip. There would be a chip somewhere controlling that power. Creating that sensing power using MOSFETs. These are the legs. These are the legs. These are the legs for the chip. These are the pins for the pins. For the chip. Okay, so one of the pins will connect on the gates of the chip. Okay, connect on the pin of the gate on the MOSFET. This is the chip, right? It controls the MOSFET, both of them. This one will always be UG, which stands for upper gate. This one will be LG, it means lower gate. Okay, I'm pretty sure you are confused, but I'm gonna make it simple for you. Let's go online again, or otherwise let's go to my PC. Let's check if I do have any schematic, and I think I do have the schematic. Come here to books. This is a schematic. Okay, so I'm just gonna open any power supply on this schematic randomly. Okay, because I want to show you how the whole thing operates. I want to show you the upper gate and the lower gate. I want to show you the naming on how they name this thing. So the chip there I was drawing now, those two MOSFETs, they can't control themselves. Okay, the purpose of those two MOSFETs is to turn on and off, on and off, on and off very fast. And then in that way they will give you a certain power. They will no longer give you 19 volts. Remember, they're taking 19 volts and they are shorting it straight to ground to create a specific voltage. Okay, using that 19 volts. Okay, no, this is the charging chip. Okay, Okay. Oh yeah. So here, as you can see, this is the power supply as well. These are the MOSFET. This is the first MOSFET, and then this is the second MOSFET. And the second MOSFET will always be connected to ground. This whole circuit here is the power supply, SMPS. It's for charging the battery. Okay, and this is the chip responsible for charging the battery. So this chip itself can't just charge the battery, but it needs the two MOSFETs. Remember, the laptop, it uses the 19 volts. This is the 19 volts coming from the sales charger B plus, and this is the 19 volts B plus. Okay, so in order for this for a laptop to charge the battery, it doesn't use the direct 19 volts. Okay, it doesn't use the direct 19 volts. Okay, it takes a certain it takes the 19 volts and then it's converted into a certain amount of voltage in order for it to charge the battery. And remember again, there is the whole aim of the power supplies, okay, is to convert a certain voltage into a certain amount of voltage. So here, the lower gate, see, it says lower drive, low drive. This is the LG, lower gate, but here they are calling it LODRV. It means the lower drive. And this is the chip. This is the chip. These are the legs. This is the chip. And these are the legs all over. And pin number 15, okay, it's responsible for lower gate. This is the gate. Where is the upper gate? Drive the higher gate. This is it. High drive. This is the one. Pin number 18. No, I'm wrong. Oh yeah, I'm right. Drive low, drive low, drive high. High drive. This is the one. Okay. Let's go back. Let's go back to our thing. Okay. Okay, we have the two MOSFETs. Okay, after the two MOSFETs, you will have what? You will have the coil. After a coil, you will have the electrolytic capacitor connected to ground. Why to ground? I'll explain why as well. After that, let's go straight to what? To the CPU. And again, we will have maybe some capacitor. Obviously, you will have some ceramic capacitors. This is the sign for a ceramic capacitor. They'll be all connected to ground. Okay, they'll be all connected to ground. Maybe we'll have 6, 1, 4. This is another one. Sorry guys, I can't draw proper parts. Hope you will get the whole idea. Oh, it's simple. Okay, this is the whole structure of the power supply. This is the power supply. Okay, it takes 19 volts and then convert it into 1 volt. This is the output. We have 1 volt. Okay, this is how the 19 volt is converted into different voltages on the laptop motherboard. And remember again, the laptop has only one main power supply, of which is the charger, and that power is 19 volts. Now the question is, where do we get the how do we get the 3.3 volts, 5 volts, 1 volt, all those different volts, 1.4 volts for the RAM one, all those different volts? How do we get those voltages? The answer is here in front of you. This is how we get all these voltages. This is how we get all those different voltages. This is how the 19 volt is converted into the 1 volt, 5 volt, or 3 volts. So these guys here, these MOSFETs here, okay, they turn on and on very fast, meaning they're getting the instruction from this chip. Okay, so if this MOSFET, this one here, if this MOSFET here, it's on, meaning what it allows power to pass from this side to this other side, right? And then automatically the chip will tell this one as well to turn on, and this one will take the whole 19 volts coming from the first MOSFET and then it will turn on. And then the moment it's turned on, it will take the whole 19 volts and short it straight to ground, meaning we will have the 0 volts, and then it will release very fast, and then we'll go back to 19 0 19 0. In this case, in this manner, we will have something like this, like a 0 19 0 19 0 19 0 19 0 19 0 19 0 19 0 19. So this is how the whole thing is converted. 19 volts here on top, let me write, we'll have a 19, and then you'll have 0 here. Okay, so actually we'll have some sparks. Okay, there should be some spark. 0 volts, over here, 0 volts. So when you calculate the whole sum of this, it would give you 1 volt. You understand? Because this thing will be turning very fast in a way that even your multimeter, it won't be able to take the measurement, to take the whole thing that is going on between the two, but it would give you the output if you are measuring from this point. Your multimeter won't be able to turn on and off and off and off. No, it won't be able to show you that thing. But if you do have the oscilloscope, it will be able to show you the whole process. If you do have the oscilloscope will show you everything in graph form and show you that on this side, these two guys are turning on and off, okay, to create a certain power. Anyway, on my next video I will explain how this whole process, this whole process from the MOSFET, how it's actually work. I will explain on my video. I will explain this whole thing, and then continue explaining one component one by one. But anyway, this is how the whole thing is converted. The whole 19 volts is converted. Okay, let me do another example again. Don't save. Okay, let's repeat this again. You have the 19 volts, I repeat again, coming from the charger. It should be flowing all over the board and 19 volts, and this is the main power, 19 volts. Let's say here you have a RAM. This is a RAM. Drawing my RAM here. Please don't laugh at me, guys. This is my RAM. RAM's got memories. Those black things on the RAM, they are called memories. There's some memories on my RAM. This is the RAM, right? Usually RAM, they are 1.5 volts or 1.3 volts. Anyway, it depends. And again, let's go online and check laptop RAM voltage. Okay. See, it depends on the type of a RAM, because here they are saying DDR4 it's 1.2, DDR3 it's 1.5. See, it depends on the type of a RAM that you are using. DDR3, which has a default RAM voltage of 1.35, so it depends on the type of a RAM that you are using. Maybe you're using DDR2, DDR3, DDR4, DDR1. It depends on the RAM that you are using. So here I'm just using 1.5. 1.5 is for its RAM, is for DDR3. You are all familiar with DDR3 because most laptops they use DDR3, but the latest ones they use DDR4. Okay, so let's repeat again. So in order to fit this RAM with 1.5, how are we gonna turn this 19 volts into 1.5 volts? Because we can't just inject 19 volts on the RAM. The RAM will burn. It's too much. It's too high. So we're gonna do the same thing. Okay, gonna have a power here supplying the first MOSFET, and then first MOSFET would supply the power to the second MOSFET. Then second MOSFET, we're gonna make sure that we connect it to ground, because it needs to short the whole power straight to ground, so that you will have the 0 and then the 19. Okay, after this, what do we have? It's always the case, we have the coil. Okay, after a coil, what do we have? It's always the case again. We have the electrolytic capacitor. I will explain why we even have the electrolytic capacitor. It's also connected to ground. After this, what do we have? We'll have a titanium capacitor. Okay, to be connected to ground as well. I can't draw, guys. After a titanium capacitor, we will have the ceramic capacitors. Ceramic capacitors will be connected to ground as well. Maybe we'll have 5, 4. It can be any amount. Okay, it can be any. Okay, the reason why we have so much capacitors, they act as filters. Okay, remember what I told you at the beginning. I said, okay, now we have the 1.5 volt. Supplying what? Supplying the RAM. And now the RAM is happy. The RAM is receiving. This is the RAM. This is the face for the RAM. Okay, the RAM is receiving 1.5 volts and the RAM is happy. The reason why we have so much capacitors in the coil, these are all the filters trying to clean, trying to make the output smooth. Okay, because remember I said at this point, let me draw. Okay, at this point, I want to explain this proper. Okay, from this point, you can't see, let me just use red. Okay, from this point, the output after this 2 MOSFET, it's very rough. Let me show you the output. The output is like this: 19 0 19 0 19 0 19 0 19 0 19 0 19 0. So rough, it's not even smooth. This is the output, this is the point. After this 2 MOSFET, we have something like this. It's 19 on top, and then it's 0 here. And the whole thing is so rough, I would like to do it so fucking rough. Okay, so rough. So now, to make it a little bit smooth, we use a coil. Okay, coils, they create a magnetic field. Okay, we all know that, to boost the electricity. So from this point, still again, the electricity will be rough, but not that rough. Okay, so we use the thing, the capacitors, okay, to smooth the output. I'll explain on my next video as well, but not on this video. On this video, my aim was to show you how the whole power supply thing works, and then we'll go more into details. Okay, so still the power is rough. After this point here, when you measure this point, maybe it's rough a little bit. Now it's starting to be smooth after this point, after the first filter, which is a electrolytic capacitor. If you check here using the oscilloscope, you will be surprised that the thing is so smooth. It's still rough, but it's so smooth. It's still in a waveform, but still it's so smooth. After this, guys, yeah, baba, it's more like a milk. Now it's smooth, going straight to the RAM, and the RAM is happy. Hope you understand the whole thing. I'm gonna stop the video, or before I stop the video, let's open the picture and see it in real life. So guys, this is it in real life. Okay, you will have the 2 MOSFETs, 1, 2. You will have the coil. This is the coil. After the coil, you have this rounding. This rounding, it's an electrolytic capacitor. The square thing, it's a coil, and these 2 black guys are MOSFETs. Then you can see even the chip here. See the chip at the behind, or here. Between the 2, one of the chip is controlling these 2 guys. Here we have 2 of them. We have 2 power supplies. As you can see, we have 4 MOSFETs, meaning it's 2 power supplies. Okay. Anyway, we can close. let's open another photo. Let's open this one. As you can see, okay, let me show you another picture. Okay, we can open any picture. Okay, very good. This is the power supply as well. You can see a coil, you can see two MOSFETs, you can see a chip. This is the CPU. This is the RAM power supply. You can see two MOSFETs. The two MOSFETs, we have the coil. After the coil, we have the titanium capacitor. After that, we have the output of the RAM. Okay. Same thing here. Two power supply, coil, titanium capacitor. After that, we have an electrolytic capacitor, and then we have the CPU. The CPU, as I told you guys, it's used. It uses two or more power supply, and I'll explain why it uses so much power supplies, because it needs more power but less voltages. I'll even explain why uh, it uses so much power supply. But anyway, I'm done. I hope you understand the whole thing. Anyway, let me just stop the video. Please watch the next one so that you'll understand more and more.